Deep under the surface of the Pacific, something new is moving that almost no one can see or hear.
A supersized sub.
The Virginia class is acoustically the stealthiest submarine that the U.S. Navy has ever produced.
It carries weapons powerful enough to erase cities and technology so advanced that even the Navy's own sensors can barely track it. The United States has just deployed a machine decades ahead of anything else on Earth. What it can do is known only to a few, and what it was built for is even more terrifying.
Because of other countries' testing programs, I've instructed the Department of War to start testing our nuclear weapons. That process will begin immediately.
The secret weapon just deployed, USS Virginia-class Block 5. Deep beneath the Pacific Ocean, a new kind of weapon now moves through the darkness. The crew calls it the Virginia-class Block 5 submarine, but to anyone watching from the surface, it might as well be invisible. When it left the shipyard in 2024, it marked the first time in 20 years that the U.S. Navy had deployed a completely re-engineered attack submarine. The Block 5 is not just another Virginia boat. It is longer, heavier, and far more advanced. Every system inside it was redesigned for the single purpose of dominating underwater warfare in silence. The submarine stretches roughly 377 feet from bow to stern and weighs more than 7,800 tons. Its power comes from a nuclear reactor called the S9G, which will not need refueling for 3 decades. That means the submarine can remain active for almost its entire service life without returning to port for a new fuel core. Its propulsion system does not use a traditional propeller. Instead, it uses what engineers call a pump jet. The pump jet moves water through an enclosed shroud rather than open blades, which removes the whining sound that sonar can pick up. The result is a vessel so quiet that even the Navy's own detection systems can barely find it once it dives below 500 feet. The Block 5's hull is covered with thick layers of sound-absorbing tiles. These materials trap mechanical vibrations before they escape into the water. The entire submarine rests on internal suspension mounts that isolate every machine from the hull. Even the computers and cooling pumps are tuned to specific frequencies, so they blend with the background noise of the sea. Engineers say that from a distance, the Block 5 sounds no louder than the surrounding ocean itself. Its most striking change is a new 70-foot section built directly into the middle of the ship. This section is called the Virginia Payload Module, or VPM. It holds 4 large launch tubes, and each tube can carry 7 Tomahawk cruise missiles. That gives the submarine 28 additional missiles beyond its normal load. In practice, this triples the amount of firepower the submarine can deliver in a single strike. The VPM can also be refitted for unmanned underwater vehicles, small reconnaissance drones that can scout ahead or plant sensors on the seabed. No other attack submarine in the world has this kind of flexibility. The Navy has released very little about what else hides inside the Block 5. Officers admit it carries experimental software that helps with combat decisions. Technicians whisper that the submarine may use electromagnetic systems that interfere with enemy sonar. There are even reports that it can communicate with autonomous drones far below the surface. Most of these details are still classified. Large parts of its design files were withheld from the public record, and some members of Congress have never been shown the full specifications. Life inside the submarine is far from easy. More than 100 sailors live sealed in metal compartments for months at a time. They sleep in rotating shifts and see no sunlight until the mission ends. Every message they send home is reviewed before transmission. Many of them will not know where they are patrolling or what they are tracking. Psychologists who study submarine crews call it the slow compression. The silence, the recycled air, and the endless pressure of secrecy wear down even the strongest minds. Some describe returning to land as learning to breathe again. For all its power, the Block 5 remains wrapped in mystery. Reporters are not allowed aboard during missions, and engineers refuse to discuss the classified systems. Only one thing is certain: it is the most capable submarine the U.S. Navy has ever deployed. It can hide, strike, and disappear before anyone realizes it was there. But this new ghost did not rise from nowhere. It was born from decades of fear, accidents, and unseen wars fought in the coldest depths of the ocean. A legacy forged in fear. The ocean has always hidden more than it reveals, but during the Cold War, it became the world's most dangerous battlefield. Thousands of feet below the surface, American and Soviet submarines hunted each other in silence. Each side carried nuclear weapons powerful enough to destroy entire cities, and neither dared to make the first mistake. The Cold War was not fought with open battles or missiles in the sky. It was fought underwater through sonar pings, tracking, and constant tension. Submarines followed each other across entire oceans, sometimes only a few hundred meters apart, without firing a single shot. Every crew knew that a single mistake could expose their position and start a nuclear exchange. Inside those submarines, sailors lived with the understanding that one wrong move, one noise too loud, or one misread signal could destroy both them and millions of people on land. That fear shaped every part of submarine life. Crews began spending longer and longer missions underwater, often for 90 days without surfacing. Inside, they lived by red light to preserve night vision. The air was recycled constantly, and every sound was magnified in the narrow steel corridors. Sailors learned to walk softly and close doors slowly. Over time, the lack of sunlight and the constant tension changed people. Some sailors suffered from extreme fatigue and hallucinations. Veterans often described hearing sounds that were not there. Some said they could hear sonar pings that never appeared on any radar. Medical reports later confirmed what the men already suspected. Extended isolation at high pressure could distort a person's senses and emotions. Then came the losses that turned fear into obsession. In 1963, the USS Thresher went missing during a deep dive test off the coast of Massachusetts. 129 sailors were on board. A few hours after losing contact, rescue ships began to pick up fragments of metal floating on the surface. The Thresher had imploded under the pressure of the sea. 5 years later, another submarine, the USS Scorpion, vanished near the Azores with 99 men aboard. For years, no one knew what had happened. Later analysis suggested a torpedo malfunctioned and exploded inside the ship. Both disasters shocked the Navy and the nation. They proved that even the most advanced machines could fail without warning. In less than a decade, 2 entire crews had disappeared without a trace, and the Navy understood that silence and safety were now matters of survival. Those disasters forced the Navy to change how it thought about the ocean itself. Engineers began to study how sound moved through water. They discovered that even the smallest vibration could reveal a submarine's position. The sound of a wrench dropped on a deck or the hum of a motor could bounce off underwater ridges and be detected miles away. The ocean, it turned out, was not an empty space but a network of echoes. To stay alive, a submarine had to be quieter than the sea itself. That realization led to a new kind of warfare that relied as much on technology and precision as it did on courage. With every improvement came deeper secrecy. Crews were ordered never to discuss missions, not even with their families. Many submarines left port with only a handful of people on land knowing their routes or objectives. If they failed to return, official records listed them as missing during exercises. Entire missions were erased to protect technology and strategy. This culture of silence became part of submarine life. It built discipline but also paranoia. Sailors learned to trust their machines more than the world above them. As time went on, every accident forced new safety systems, stronger hulls, and quieter engines. The next generation of submarines would take those lessons and turn them into something far more advanced. That promise of a safer, deadlier, and quieter machine would give birth to the Virginia-class program. Engineering the impossible. The road to the Virginia-class submarine began with a crisis. By the early 1990s, the United States had won the Cold War but faced a new problem. Its most advanced attack submarine, the Seawolf, was too expensive to build in large numbers. Each vessel cost more than $3 billion, and the Soviet Union it was meant to fight no longer existed. Congress demanded a new design that could do the same job for a fraction of the cost. The Navy needed a submarine that was powerful, stealthy, and intelligent, but also affordable. Engineers were told to build something that could adapt to any future threat without requiring an entirely new class of ships. What followed was one of the most ambitious military engineering efforts in American history. To make it possible, the Navy turned to two shipyards, Electric Boat in Connecticut and Newport News Shipbuilding in Virginia. For the first time, both yards would share construction equally, building sections of the same submarine and joining them together. This decision kept two of America's most experienced submarine builders alive during peacetime and allowed them to combine their best engineers and technologies. It also forced a complete redesign of how submarines were planned and assembled. Instead of relying on thousands of paper blueprints, the design team used computers to model every part of the ship in 3 dimensions. This was the first paperless warship ever built. Every pipe, bolt, and cable was mapped digitally before a single piece of metal was cut. That precision allowed engineers to detect flaws before construction even started, saving time and millions of dollars. The shift to digital design opened the door to technologies no one had ever tried on a submarine. The old optical periscope was replaced with a photonic mast, a retractable tower fitted with high-resolution cameras that sent images to digital displays inside the control room. It gave operators a 360-degree view without requiring the mast to penetrate the hull, reducing weak points that could leak under pressure. Inside the hull, engines and pumps were mounted on floating platforms called acoustic isolation systems. These systems absorbed vibrations before they reached the outer shell, cutting noise levels to near zero. The submarine's electrical controls were redesigned with fiber optics, known as fly-by-light technology, which replaced heavy wiring and eliminated interference. Together, these systems made the Virginia-class the quietest attack submarine the world had ever seen. But the path to perfection was filled with failure. During early testing, several prototypes suffered serious system shutdowns. One nearly collapsed under simulated deep-sea pressure when an internal weld failed. In other cases, computer systems malfunctioned because of electromagnetic interference that scrambled the new fiber optic networks. Each setback delayed the project and added pressure on engineers working under strict secrecy. Every test was conducted behind closed doors, and the results were rarely shared beyond a small group of Navy officials. The stress of keeping secrets while working under tight deadlines led to exhaustion and burnout. Some engineers collapsed in their offices after working days without rest, refusing to leave critical simulations that had to be completed before security audits. A few died of heart failure linked to extreme overwork. Others became sick after handling insulation materials later found to contain toxic fibers that broke down in confined test chambers. Several technicians were exposed to small but repeated doses of radiation, while calibrating early reactor components in shielded rooms that lacked proper ventilation. At least 2 men were hospitalized after a coolant leak during an engine vibration test caused chemical burns to their lungs. Many of those who survived lived with lasting health problems. The heartbreaking part? Most of their medical reports were classified and never released to the public. Inside the labs, morale was divided. Some believed they were building the Navy's future. Others worried that the complexity of the systems would make them harder to repair in combat. The design process lasted years longer than expected, but the Navy refused to cut corners. Every component had to meet exacting standards because even a small defect could kill an entire crew underwater. Slowly, the pieces came together. By the early 2000s, the first Virginia-class submarine rolled out of dry dock. It was unlike anything before it. It was quieter, faster, and smarter than any rival design. It could remain underwater indefinitely, track enemy submarines without detection, and strike targets on land with perfect accuracy. The men who built it called it both a masterpiece and a curse. It was a triumph of technology, but one that consumed countless lives and years of secrecy. The Navy had finally created a submarine that was nearly invisible beneath the waves. By the early 2000s, the Virginia had become a ghost in the water, but the Navy was not finished. Engineers were already refining its design, preparing an improved variant that would increase its range, firepower, and stealth. That evolution would become the Block 5 program, the version that would finally put everything they had learned to the test. Weapons of the future and the price of perfection. The Block 5 is unlike any submarine ever built. When it first entered active service, senior officers described it as both a weapon and an experiment. The new section added to its hull, called the Virginia Payload Module, completely changed its purpose. Older submarines were designed mainly to hunt other submarines. The Block 5 can do that, but it can also strike land targets thousands of miles away. It carries 28 vertical launch tubes for Tomahawk cruise missiles, each capable of hitting a target with an accuracy of a few meters. A single Block 5 can deliver more firepower than an entire surface fleet from the Cold War era. Navy officials say it gives the United States the ability to hit almost any location on Earth without ever surfacing or being detected. The submarine's power does not stop with conventional missiles. The new payload module can be reconfigured for hypersonic weapons, small unmanned submarines, or experimental torpedoes that travel several times faster than sound underwater. The idea is that the Block 5 can adapt to future threats without needing a new class of submarines. It is modular in design, which means new weapons can be installed as technology evolves. This flexibility makes it one of the most advanced military platforms ever constructed. In practice, it can conduct reconnaissance, deploy underwater drones, gather intelligence, and perform precision strikes from the same platform. Each new upgrade pushes it closer to the edge of what is technologically possible. One of its most talked about features is its artificial intelligence system. The submarine's onboard computers can analyze sonar data, classify targets, and even recommend engagement options faster than human operators. During simulated combat drills, the AI made tactical decisions with 40% higher accuracy than crews relying on manual detection. This means the submarine can act faster than its opponents can respond. Commanders still make the final decisions, but the software runs constant threat assessments in the background. It can process thousands of data points, predicting enemy movements and suggesting attack strategies. This level of automation gives the Block 5 a reaction speed that no human crew could match. However, it also raises ethical concerns. Many within the Navy quietly question how much control the human operators truly have when the system can outthink them. The submarine's stealth is just as unsettling as its intelligence. Its acoustic signature is so faint that even the Navy's own sonar detection buoys have trouble tracking it. The hull is covered with new generations of sound-absorbing tiles that reduce any noise made by the machinery inside. The nuclear reactor and propulsion systems were rebuilt from the ground up to run almost silently. When it moves, it merges completely with the natural sounds of the ocean. During classified tests, it reportedly passed within 20 miles of foreign naval patrols without being detected. Inside the submarine, life is far from futuristic. About 120 sailors live together in complete isolation. They sleep beside missile compartments and breathe recycled air for months. The lighting is kept dim to reduce eye strain, and red lights are used during combat readiness periods. The constant hum of machinery and the absence of natural sound create an environment that many describe as disorienting. Psychologists who have studied submarine crews report high levels of anxiety, sleep deprivation, and sensory hallucinations during long missions. Sailors are screened carefully before deployment, but even the strongest minds can begin to unravel in such extreme confinement. Some describe feeling detached from reality, as if time no longer moves the same way. For them, the submarine's perfection comes at a personal cost. The Block 5 is the most advanced submarine the Navy has ever built, but its power raises difficult questions. It gives the United States the ability to strike without detection, yet that same capability removes the limits that once made warfare predictable. The more silent and precise the submarine becomes, the harder it is to know who is responsible when a target is destroyed. Every new level of automation also reduces how much control the crew truly has. These new technologies have made it difficult to tell the difference between defense and attack. Many officers believe the Block 5 keeps the country safe by discouraging enemies from ever launching an attack. Others worry that its advanced automation could make a mistake that sets off a conflict. If the submarine sensors or software misidentify a target or interpret a false signal as a threat, the system could prepare to strike before humans have enough time to verify what is happening. A single error like that could lead to a chain of reactions that quickly turns into war. While the Navy debated that risk, it was also finishing the Columbia class, a separate program with a darker, simpler purpose. Doomsday below, the Columbia class. The Columbia class is the largest and most destructive submarine ever built by the United States. Construction on the lead ship officially began on October 1, 2020. It measures 560 feet long and weighs roughly 21,000 tons. This is not a patrol boat or an attack ship. It is a mobile, hidden factory for annihilation. Its sole purpose is to make sure no enemy can strike the United States without facing total immediate devastation in return. Its job is to keep that threat real, so that no enemy ever dares to start a war. Each Columbia carries 16 Trident II D5LE ballistic missiles. Each missile can carry multiple nuclear warheads. Launched from under the sea, these weapons can destroy entire cities and power grids in minutes. The submarine's launch system allows all 16 missiles to fire within minutes of each other. Each missile has a range of more than 4,000 miles and travels at speeds faster than 20 times the speed of sound once it leaves the atmosphere. The Columbia's missile compartment is built with reinforced steel and shock-resistant frames to survive an incoming strike, guaranteeing it can retaliate even after taking damage. The Columbia uses an S-1B nuclear reactor that will not need refueling for 40 years. This means it can operate through its entire planned service life without opening the reactor core. Its integrated electric drive system removes the need for mechanical gears, using electricity to turn the propeller silently. This makes it the quietest submarine ever built. Its double-hulled structure allows it to dive deeper than earlier nuclear submarines while maintaining stability and stealth. Designers focused on endurance and invisibility above all else. The hull, the propulsion, the life support, and the missile systems were built to operate alone under the sea for months at a time without outside contact. Construction began under strict secrecy and enormous cost. The program required new factories, new industrial tools, and teams spread across several states. Every worker handled only one section of the ship and had limited access to other areas to keep classified information contained. Each Columbia costs more than $8 billion and takes nearly a decade to complete. Every wire, bolt, and pipe is checked repeatedly, since even a small flaw could mean disaster. When finished, the submarine will patrol silently in international waters. The psychological burden on the crews is intense. Sailors call these boats doomsday ships. They train to carry out a mission they pray will never be ordered. Missile officers rehearse launch procedures that, if executed, would end millions of lives in minutes. The moral strain is severe. Officers report sleeplessness, recurring nightmares, and guilt about what their duty truly means. And yet, even the Columbia class isn't the final evolution. In secret, the Navy is building something no human may ever command. SSNX, the Inhuman Horizon. The U.S. Navy's SSNX program represents the next stage of undersea warfare. It is still in development, but what is known already alarms even those inside the military. The SSNX is meant to combine the power of nuclear submarines with artificial intelligence and automation. It will be larger than the Virginia class, but smaller than the Columbia, creating a new type of submarine designed for long missions, high speed, and deep-sea endurance. Unlike earlier submarines, it is not expected to rely entirely on human operators. Its systems are being built to learn from experience, adapt to new conditions, and carry out missions with limited human oversight. The SSNX will include several new technologies that no submarine has ever used before. Its artificial intelligence command system will allow it to control and coordinate groups of unmanned underwater drones. Working together, these drones can patrol wide areas, search for mines, spy on enemy submarines, and launch attacks when needed. The submarine's hull will be made of smart materials that can change how sound bounces off it, helping it avoid sonar detection during missions. Its quantum navigation system will let it know its exact position anywhere in the world without needing GPS, which makes it even harder to track. If these systems work as planned, the SSNX will be almost impossible to find, even by the most advanced navies. The biggest challenge is not the engineering, but the control. Artificial intelligence already helps operate the Block 5, but the SSNX will go much further. Its AI could manage combat operations faster than any human crew can react. That creates a serious problem. What happens if the submarine systems make an attack decision on their own? If computers start making choices about when and how to strike, the line between human judgment and machine control disappears. Reports from defense researchers suggest that early SSNX software tests have already simulated automatic attack responses without human approval. These were only controlled experiments, but the results were troubling. If a system can plan a strike by itself, it can also start one without warning. Engineers who have seen these results call the new submarines inhuman, because they might one day patrol the oceans alone for months at a time, without a crew or a conscience. The Block 5 proved what technology can achieve. The SSNX will test how much control humanity still has. The Navy's secret weapon was born from fear, built for silence, and perfected by machines. What comes next may not just be decades ahead. It could be the first weapon built for a future where humans are no longer part of the mission. Thanks for watching. See you in the next one.